classification of differential equation by linearity. An nth order ordinary differential equation is said to be linear if f is linear in the dependent variable and it's all the derivatives up to the order of n. That is, it has the following form as shown in the box. Note that the coefficients of the derivatives of y in the left hand side are all functions of x only, and in the right hand side we have some known function of x. In particular, a sub 1 of x times y prime plus a sub 0 of x times y equals some function of x is a first order ordinary differential equation. This is the linear equation. Similarly, the second equation we see here is a second order linear ordinary differential equation. For example, y double prime minus 5y prime plus 6y equals 0 is a second order ordinary differential equation in y, which is linear. And we will talk more on this linear ordinary differential equations throughout this course. If an ODE is not linear, then it is called a nonlinear ordinary differential equation. For example, y prime equals y squared is not a linear equation, hence a nonlinear equation, because in the general form of a first order linear differential equation has no y squared term. For the similar reason, the second equation we see here is also a nonlinear ordinary differential equation. And the third equation, since the coefficient of y prime is a function of y, this is not a linear equation, hence a nonlinear equation. In the study of differential equations, we sometimes encounter systems of differential equations. This system has two equations. There are two dependent variables and one independent variable, possibly t. So you can also read this equation as dx by dt equals x plus y, dy by dt equals x minus y. So this is a system of ordinary differential equation. Similarly, this system is consisting of two equations, each of which is a partial differential equation. These equations are called Cauchy-Riemann equations in complex analysis, and it's important in the theory of analytic functions.